All right, so this is going to be part 1 of chemical texture services for cosmetology. So we're going to explain the 4 chemical reactions that take place during permanent waving. We're going to explain the difference between an alkaline wave and a true acid wave. We're going to explain the purpose of neutralization in permanent waving and demonstrate safe and effective perm techniques. We are going to describe how Thio relaxers straighten the hair, describe how hydroxide relaxers straighten the hair, demonstrate safe and effective hydroxide relaxing techniques, describe curl reformation and how it restructures the hair. And so we're going to first talk about permanent waving, relaxing, and curl forming. Okay, so we got to go back to the basics. So this is the outer shaft of the hair. This is the cuticle, the toughest outer layer of the hair. It surrounds the inner layers and protects the hair from damage. So the cuticle layer is on the outside. The cortex is the middle layer of the hair and is located beneath the cuticle. It's responsible for hair strength and elasticity. So please remember that the hair's strength and elasticity comes from the cortex. So that's the middle. And then we have the medulla. This is the innermost layer of the hair, often called the pith or the core of the hair. It does not play a role in restructuring. And it's actually even missing in some types of hair, like really, really fine hair probably doesn't have a medulla. So in your textbook on page 599, they show some pictures and they talk a lot more about everything. So please remember, read your textbook, especially this chapter is huge and there's so much more that you need to know than we're able to talk about in the PowerPoints. Okay, so this is super important, not only in hair chemical texture services, but in all chemical services on the hair and skin, and even on the nails. pH means the potential hydrogen. It represents the quantity of hydrogen ions and measures the acidity and alkalinity of a substance. So the pH scale has a range of 0 to 14. 7 is neutral. So on the pH scale, 7 is neutral. Below 7 is acid. So 0 to 7 is considered acid. And above 7 is alkaline. So 7 to 14 is considered alkaline. So some might say 0 to 6 is acid and 8 to 14 is alkaline because 7 is neutral. But just remember, below 7, acid, above 7 is alkaline, and 7 is neutral. And the pH of the hair is 4.5 to 5.5. I can pretty much guarantee that's going to be a test question. Not only here with me, but in State Board on your written exam. So make an extra note that hair is 4.5 to 5.5 on the pH scale. So the building blocks of the hair. So we have amino acids. Amino acids are compounds. They're made of carbon, oxygen, hydrogen, nitrogen, and sulfur, okay? So remember that amino acids are carbon, oxygen, hydrogen, and sulfur. And then there's peptides. Those are the end bonds. So peptide bonds are chemical bonds that join the amino acids together end to end in a long chain to form polypeptide chains. So we have the amino acids, those kind of look like the beads on a strand. And then we have the peptide bonds, those are the bonds that join the beads of amino acids together. And when you get more than 2 amino acids joined by peptide bonds, those are called polypeptide chains. So poly meaning more than one, polypeptide chains. So we have polypeptide chains that are formed together by peptide bonds that are linked together. Then we have keratin proteins. Those make up about 97% of the hair structure. Then we have side bonds. Side bonds are dual sulfide, salt, and hydrogen bonds that cross-link polypeptide chains together. So if you look in that little illustration there, you'll see that there's the polypeptide chain, there's the keratin proteins, and then there's the side bonds, okay? So they link the polypeptide chains together, and you can see what they're made of. They're made of disulfide, salt, and hydrogen bonds. So those link the polypeptide chains together. And page 600 starts talking about it and on. And then we have keratin proteins. So in the last one, we talked about keratin proteins, but here we're going to talk a little more. They're made up of long coiled chains of amino acids that are linked together end to end like beads by the end bonds. Okay, so the keratin proteins, you can see them there. The keratin proteins are made of long chains of amino acids that are linked together like beads. The amino acid chains are linked together by peptide bonds, as we said earlier, and these chains of amino acids are linked by peptide bonds called polypeptides. We talked about that earlier. Keratin proteins are made of long coiled polypeptide chains, which in turn are comprised of amino acids. So the keratin bonds are kind of coiled, like they're kind of like curled polypeptide chains. Then we have disulfide bonds. So those we talked about earlier, they are formed when sulfur atoms in two adjacent protein chains are joined. Only are able to be broken by chemicals. Account for about a third of the hair's strength. So when we're doing chemical texture services, we want to break these bonds down, okay? We have salt. So we're talking now too about side bonds. So this was a side bond, disulfide is a side bond, and now salt is a side bond. So salt is a relatively weak physical side bond, resulting from an attraction between the negative and positive electrical charges. It can be broken by water. It accounts for about a third of the hair's strength. So that's easy to break. Hydrogen bonds are weak physical side bonds resulting from an attraction between opposite electrical charges, easily broken by water, and they account for about a third of the hair's strength. So side bonds and hydrogen bonds are very similar. Physical change is caused by wrapping the hair on tools. So chemical change is caused by the processing of waving solution and neutralizer. Okay, so I want you guys to understand the difference between physical change and chemical change. So physical change is just caused by wrapping the hair. It could just be with heat or maybe even just with water drying. The chemical change is more of a permanent change, and that's caused by the processing of the waving solution and the neutralizer. So the waving solution is going to soften the hair up and start to break those bonds, and then the neutralizer is what reforms, it restructures the hair into the shape of whatever it's on. Okay, and this will make more sense later. So the chemistry of permanent waving. Okay, so we have alkaline solutions. Alkaline solutions are stronger than acid solutions. Alkaline solutions soften and swell the hair, and they open the cuticle. And acid solutions result in far less swelling of the hair than alkaline, because alkaline is stronger than acid. And you can see how much more the cuticle is open on the alkaline solution. It's blown way open. And on the acid solution, it's just open a little. Once the waving solution is in the cortex, it breaks the disulfide bonds through a chemical reaction called reduction. So that's important to remember. Reduction involves either the addition of hydrogen or the removal of oxygen. So either one would be a reduction. So either the addition of hydrogen, so adding water, or the removal of oxygen. Thioglycolate acid. This is a colorless liquid with a strong, unpleasant odor. Is the most common reducing agent in a permanent wave solution. Ammonium thioglycate, which is also called ATG, is the addition of ammonia to thioglycolate acid, and it produces ATG, which is alkaline and is the active ingredient or reducing agent in alkaline perms. Okay, so here are some different types of permanent waves. So we have at the top there, so you can see the pH scale, 0 to 14. So on the top, we have low pH waves. That is 6.5 to 7.0. Then if you go to the right, it's higher on the pH scale, and that's the alkaline or the cold waves, and that is 9.0 to 9.6. That's super strong. Below that, we have 7.0 to 9.6, so that can be neutral and it can go really, really strong. Those are thio-free waves. And then below that, it's the same pH, ammonia-free waves. Then we have acid balance waves, which are 7.8 to 8.2. Those are my favorite to use. They just give you a nice curl with still keeping the hair structure intact. And then to the right, we have 9.0 to 9.8. It's an exothermic wave. That's very strong. And then to the left, the green one, true acid wave, 4.5 to 7.0. Those are very weak. Those are better if someone says that they just want a body wave. It's not going to give a tight curl. It's just going to give a wave. So those are the different types of permanent waves. So we have, now we're going to talk about them. We have alkaline waves or cold waves, acid waves, true acid waves, exothermic waves, and components. Endothermic waves, ammonia-free waves, thio-free waves, and low pH waves. So when selecting the perm type, let me see what page this is on. This is on page 606, your textbook. So these are the things that you're going to need to take into consideration. To the far right is the recommended hair type. So coarse, thick, or resistant. We have extremely porous or very damaged. We have porous or damaged. We have porous to normal and normal, fine, or damaged. So if you notice the thicker, more resistant, coarse hair, it's got the higher pH. So this is going to be the alkaline perms. And then let's see, if you go to the bottom, the normal, fine, or damaged, this is the low pH waves, 6.5 to 7. And the true acid waves would be for extremely porous or very damaged hair. That's kind of the upper middle. That would be the 4.5 to 7.0. And those are called endothermic. And in your book, it talks about the difference between exothermic and endothermic. We might be able to talk about it here too. But anyways, so this, where it says extremely porous or very damaged hair, this is hair that is porous due to usually coloring or bleaching, but I don't recommend perming hair that's been bleached. The reason for that is because the medulla and the cortex already have been damaged, and there's not really much, there's probably isn't any elasticity left in hair that's been bleached a lot. So it's not even going to be able to grab onto the curls. What will happen is the new hair, the roots will have a nice great curl, and then all the hair that's damaged is going to be straight. So don't do that to yourself. Don't do that to the client. You just have to tell them, they need to wait, get some haircuts, get their hair in better condition, and then you can perm it. So you can perm the hair if it's just been highlighted, as long as it's healthy, as long as it has elasticity. But if it's really, really bleached and really damaged, I don't recommend it. If the client has hair that's somewhat damaged, then go for a true acid wave. So permanent wave processing. The amount of processing time should be determined by the strength of the solution, not necessarily how long the perm is processed. And honestly, you need to just read the instructions on the perm. The manufacturer's instructions are the way to go. Every perm box should have it either on the box, inside the box, or in like some paper directions. Because every perm is different, every brand is different. Most processing takes 5 to 10 minutes. Additional time allows polypeptide chains to shift to new configuration. And you also want to consider the hair. So the more damaged it is, the less time you want to leave it on. So over-processed hair does not mean overly curly. This is what I was talking about earlier. If too many disulfide bonds are broken, hair is too weak to hold a firm curl. It has a weak, it is weak, or the curl may be completely straight. Hair at the scalp is stronger, so that's why the hair at the scalp will be nice and curly, and the ends will be straight. That's what I was talking about earlier. Underprocessed hair, it could be resistant hair, gray hair. If too few disulfide bonds are broken, hair will not be sufficiently softened and will not hold the desired curl. Hair at the scalp is not as curly as the ends. More processing time is required. So this is because possibly if the hair is very coarse or if it's gray, so it's resistant, you need to give it a little bit more time. Otherwise, it's going to look like this. The ends are naturally going to be a little bit more porous because they've been in the elements longer. They've been, heat styled longer and possibly colored. So they're going to be more porous. So it'll take the curl better. But if it's too resistant on the roots because it's, either gray or coarse hair, then it needs a little bit more time. So now we're going to talk about Thio neutralization. So first you do the waving solution and then we go to the neutralization. So the Thio neutralization stops the action of the waving solution and now it rebuilds the hair into its new curly form. It produces two functions. It deactivates the waving solution and it rebuilds broken disulfide bonds. So the waving solution is softening the hair and it's breaking apart the disulfide bonds. But the neutralization comes in and it rebuilds the disulfide bonds, and now the hair forms whatever shape that it's wrapped around. This happens during the Thio neutralization. So neutralization, stage 1, you rinse the hair for 5 full minutes. Then you're going to towel blot the hair thoroughly but gently. So you want to get it as dry as you can, but don't move the hair out of place too much with the towel because remember, it's going to take the form of whatever it's wrapped around. So if you dry it off with a towel, but you rub too hard and you're aggressive with it, then you're going to have hair sticking out and it's going to be like some straight pieces from what you messed up and then some curly ones that are still wrapped around. And so you want to just gently pat the hair dry. You want to get it as dry as you can, but by patting it. If directed, apply a pre-neutralizing conditioner to strengthen the hair. So proper rinsing and blotting, you're going to rinse with warm water. You're always going to use a gentle water stream. And don't use cold water, guys. Use warm water. As hot as they can stand it, but don't hurt them. Avoid pressure on the rods while rinsing. So you don't want it to be like the water to be shooting really hard. You want it to be a gentle stream. You're going to rinse the most fragile areas first. Thoroughly rinse the nape area and rod bottoms. A lot of people forget about that because they're leaning back on that area. Make sure that you really, really rinse it, and especially because a lot of times in the nape area, people's hair is a little bit more porous. So you want to make sure not to burn that hair off. And then you're going to rinse it for the recommended time. So you're going to need to read the instructions. You're going to smell the hair. And if you can still smell that perm, I mean, you will still smell something even if it's all the way rinsed out. But if you can smell it really strong, you need to rinse it a little bit longer. Continue rinsing if needed. And over rinsing is not going to hurt when you're rinsing out the neutralizer. Because they could go home and jump in the shower and just wet their hair, not shampoo it, not condition it, but just wet it as much as they want. It's not going to take any of the perm out. So you can over rinse it, but you don't want to under rinse it. So then you're going to gently blot the hair with a towel, check for excess moisture, especially at the nape, and adjust any loosened or drifted rods. Then stage 2, the disulfide bonds are broken with hydrogen. So they're broken with hydrogen. The disulfide bonds are now rebuilt. The hydrogen bonds attract the oxygen. Water molecule is formed. So we have hydrogen and we have oxygen. Now that's all they need to bond back up. Water molecule is formed, water is removed, side bonds are now reformed. Preliminary test curls. So you want to test the hair to make sure it's curled. So you're going to make sure that you're using the correct processing time. You're going to have the expected results from the solution. So that's the time that you'll check it. And then is the curl will be expected from the rods, like the curl expected from rods and wrap. How much color will be removed from the process if the client has color treated hair? So you do need to, let the client know that this is going to fade their hair color a little bit. Will the integrity of the hair be compromised? Did the hair break? Is it dry, frizzy? Is the client satisfied with the shape and hold of the curl? Okay, we're going to stop there. And please read your textbooks up to page 609.